Yes, welcome back to the next session of Rehabilitation and Retrofitting of Structures course. In the last session, we have been discussing or we have been learned the various testing system that will be used to assess the concrete structure or reinforced concrete structure. In that, we have been discussed the destructive testing system, semi-destructive testing system and non-destructive testing system. In that destructive testing system, we have been learned one particular test that is called load test. Okay. So the load test is predominantly used to assess the strength of a concrete, which will be tested in terms of destructive method of testing or evaluating the strength and quality of a reinforced concrete structure. So next, you will come across a situation called, or you will come across a situation in the site, you need to perform or dependent on the other type of testing system, because in the last session have been discussed, we cannot use all the testing systems in the field, or in the lab. We need to use or depend upon the particular type of testing system to assess the strength and quality of a reinforced concrete structure. So now, when you are not going to perform a destructive method of testing to assess the strength and quality of a concrete structure, we need to rely upon the other method of testing system, that is second one called semi-destructive testing system or technique. So what is the meaning of semi-destructive? Semi-destructive testing means it is assessing the performance like strength and quality of a concrete structure. I will repeat. It is assessing the performance such as strength and quality of a reinforced concrete structure with partial disturbance of neighboring concrete. That means I am going to disturb the neighboring concrete. With the disturbance of a neighboring concrete or the concrete I am undergoing which is going to perform. So that disturbance will be made. With that disturbance I am going to assess the strength and quality of a concrete. So that is called as semi-destructive testing system. So let us know one by one. So these are all the various semi-destructive testing techniques we can be performed in order to assess the strength and quality or a performance. Now coming to the first one, penetration technique. Penetration test or penetration technique. Second one, pull-out and pull-off test. Pull-out and pull-off test. Third one, core sampling and testing. Core sampling and testing. Number 4, break-off test. Number 5, off-cell potential survey. Number 6, carbonation and pH value test. Number 7, chloride content test. So these are all the various tests we are going to perform in order to assess the performance of a concrete structure. So in that I am going to discuss the widely used semi-destructive testing systems. As per Indian specification, core sampling and testing is predominantly used semi-destructive testing system in order to assess the strength and quality of a concrete structure. And another one is carbonation and pH value. So this is the one more test they are going to perform predominantly to assess the quality of a concrete or reinforced concrete structure. And other tests we are not going to use widely, but these tests we need to know, because these other tests that is like penetration test, pull-out and pull-off, all these tests they are going to use in other countries. But in India, mainly we are going to use a core sampling and testing. Is it clear? So let us know one by one. So coming to the first one, the penetration technique. That is Windsor probe test or penetration resistance test. That is Windsor probe test or penetration resistance. Please underline this sentence, penetration resistance test. Let us know what is that. In 1964 and 1966, a technique known as Windsor probes. Windsor probes was advanced for testing concrete in lab and in situ. This particular Windsor probe or penetration resistance test is widely used in, or I can say it can be used both in the laboratory as well as the site. So this particular test we can use both in the laboratory and the site. Okay, I will tell you what is that probes, okay, in the next slides, in the coming slides. So, what is the fundamental principle involved behind this test? So, this Windsor probe is just like a rebound hammer. What is it, rebound hammer? So, this is the predominantly widely used non-destructive testing system which I am going to discuss in the next session. Okay. So, this works, the Windsor probe will works just like a rebound hammer. That means I am going to use this testing technique, equipment or a technique, okay, as a hammer, okay, and that particular equipment is going to hit the concrete surface, or it will penetrate the concrete surface inside the concrete, okay, and we can assess the strength of a concrete. So, like that we are going to measure. So, that is why you can see here the Windsor probe, like the rebound hammer, is a hardness tester, and its inventors claim that the penetration of a probe reflects the precise compressive strength in a localized area is not strictly true. Okay. See, you can look at here. So, these are all called the probes. This is called the probes. Okay. These probes are going to penetrate inside the concrete member. These probes are going to penetrate inside the concrete member. Through these probes, I am going to assess the compressive strength. But whatever the compressive strength you are going to determine will not be realistic in nature. That's what. There will be limitations. In rebound hammer also, whatever the test I am going to perform, okay, as that of Windsor probe, that is not so realistic. That means the actual compressive strength varies from the tested compressive strength. There is a quite difference, which I am going to specify in the further session. Is it clear? Okay. Next. However, the probe penetration does relate to some properties of a concrete below the surface. However, whatever the probes we are going to penetrate inside the concrete, okay, that particular will relate to the property of a concrete. That property we are going to assess is strength, which I am going to explain now. Okay. And it has been possible to develop empirical correlation between the strength and the pen. That's what. Whatever the penetration I am going to perform inside the concrete, so that will be correlated with the strength. How much is the penetration? So, for example, simply I want to explain the principle. Better the penetration resistance by a concrete member, better will be the concrete strength of that particular reinforced concrete. For example, if I am going to insert or penetrate that probes inside the reinforced concrete slab, okay, if that reinforced concrete slab is strong enough to bear or will not allow any probes to penetrate inside, that means it is clearly indicating that the strength of that particular reinforced concrete slab is good, because it is not allowing that penetration probes to enter or penetrate inside the reinforced concrete member. Is it clear? So, that is what the fundamental principle. We are going to measure that length. What is the penetration that has been happened? That I am going to explain in the further session, step by step procedure. Okay. And also I am going to show you a small video. Okay. Next. So, these are all the equipments. You can see the equipments. The equipment used in Windsor probe or penetration resistance are powdered actuated gun or a driver. So, this is what a powdered actuated gun or a driver. So, this is the one technique or equipment, and also we can use this particular equipment also. You can use a powdered gun or you can use a driver. Both you can use it. Okay. Next, hardened alloy steel probes. Hardened alloy steel probes. Okay. So, these are all called the steel probes. You can see here, these are all called the steel probes. You can see here, it will be having a screw end. Okay. It will be plain surface. It will be have a roughened end. So, this roughened end is just going to penetrate inside the reinforced concrete member. Next, the loaded cartridges. Okay, so these are all called the loaded cartridges. Okay, and next you can use a depth gauge. So, depth gauge there is not in the photo, which I am going to show you. So, the depth gauge they are going to use in order to measure how much that probes has penetrated inside the reinforced concrete member. Is it clear? For example, if this is the probes, how much this probes has been penetrated inside the reinforced concrete member, so that we can measure using this, okay, the depth gauge. So that's what the depth gauge for measuring the penetration of probes and other related equipments. So these are all the equipment they are going to use. That is powder actuated gun or drive, steel props, okay, and then depth gauge. So these are all the equipments they are going to use in order to perform the Windsor probe test or penetration resistance test. Next, as the device looks like a firearm, okay, firearm, it may be necessary to obtain official approval for using some country. That's what. This was the limitation. In majority of the countries, this test has been banned because it will be very harmful and they are going to use it for some other purpose, okay, apart from testing concrete member. So that's why they have been banned this particular test. And what exactly it comprises of exactly, let us see. The props having a tip diameter of 6.3, a length of 79.5. So this length will be 79.5 and the tip diameter will be 6.3 mm and a conical point, okay, it will be having a conical point. So that conical point, why it will be there? That conical point will be there for easy penetration inside the reinforced concrete member, okay. Next, the probes of 7.9 mm are also available for the testing of concrete made with lightweight aggregate. For example, we can also use it for a lightweight aggregate concrete also. For that, the probe diameter will be 7.9 instead of 6.3 mm. Next, the rear of a probe, that means at the top of the is threaded and screws. You can see here, it will be threaded, okay, and it will be screwed, okay. It will be attached with a screw into the probe driving head, which is 12.7 mm dia. Okay, so that screw will be of, so this screw will be of 12.7 mm in diameter. Next, and it fits snugly into the bore of the driver. So attachment obviously will be fit perfectly. The probe is driven into the concrete by firing of a precision powder charge that develops energy of 79.5 meter per kg. So whatever you are going to impact, that impact will be emerges with energy of, this is the energy, okay. For the testing of relatively low strength concrete, the power level can be reduced by pushing the driver head further into the barrel. So okay, you can operate for a lightweight concrete member also, or lightweight concrete member, light strength concrete member by pushing the barrel. So these are all the equipments which have been told. So now let us get into the step-by-step procedure. So this procedure will be there as per ASTM C803. ASTM means American Society for Testing and Machine. Okay. So this particular testing code, okay, they have been given. What is the procedure they are going to follow? Okay. So this is the procedure will be given by American code. Okay. Let us see that. The area to be tested must have a brush finish or a smooth surface. That means we need to clean off a surface on which you are going to perform the test. That is the first step. To test the structure with coarse finishes, the surface first must be ground smooth in the area of the test. For example, if there is any rough finishing, the coarse exposed, that means not so flat. Okay, at that particular we need to finish off the surface to the flat level. Okay. Briefly, the powdered actuated driver is used to drive a probe into the concrete. So that's what they are going to use to drive the probes into the concrete. In the flat surface are to be tested. So we are going to create a flat surface. Okay, the flat surface are to be tested. A suitable locating template. A suitable locating, that means, okay, after choosing a flat surface in which you are going to perform, we need to select a location. Okay, that location we are going to select with respect to template to provide. Why the template? Why? Because we are going to create an equilateral triangular pattern. We are going to create an equilateral triangular pattern. So which that equilateral triangular pattern, that means, for example, so like that it will be there. See here, if it will be like this, I am going to create an equilateral triangular pattern. So like this, I am going to create a probes. Okay, so hence, okay, so I need to create a pattern somewhat like an equilateral triangle. So this will be something like this. This will be something like an equilateral triangle. So like this I am going to create a surface. Okay. So that will be, that's what 178 mm equilateral triangular pattern. So this will be 178 mm equilateral triangle. Okay. And 3 probes are driven into the concrete, one at each corner. You can see here, one at this corner, one at this corner, one at this corner. Okay, so in all the three corners I am good. Why I am going to penetrate these three probes? Because by penetrating the one probe only I can make out the what I can say the penetration resistance. But why 3? Why? Because I need to take an average of these three values. Why? Because sometimes there is a chance that one particular probe cannot penetrate inside because there will be disturbance from the coarse aggregate. That means the coarse aggregate will not allow the probes to penetrate inside. So that's why we are going to penetrate the three probes inside and measure the average of 3. Next, a depth gauge measures the exposed length. That's what, after penetrating that probes, the exposed length will be measured, which I am going to show you in the video. Next, the manufacturer also supplies a mechanical averaging device. Okay, we can measure. Okay, they are going to supply the device. We can mechanically average that. Okay, for measuring the average exposed length. Okay, the mechanical averaging device consists of 2 triangular plates. The reference plate with 3 legs slips over the 3 probes and the rest on the surface. That means we are going to provide a plate on that. Okay, this is the penetration. Okay, they are going to provide a plate here. On that particular plate, this particular probe will be resting. Okay, so that you can firmly fix that measuring gauge on that particular reference plate, so that you can measure perfectly without any undulations. Okay. The other triangular plate rests against the top of the 3 probes. Okay, one will be at the bottom, one will be at the top, so that you can measure clearly. In between these 2 reference plates, you are going to measure those, okay, or measure that particular linear dimension exposed, okay, of a probes. Next, the distance between the 2 plates, that's what. Okay, so whatever the penetration that has been driven, okay, between those 2 plates, okay, I am going to measure the distance, okay, and I am going to take the average of the 3 probes. Okay, insert the bottom plate, insert the top plate, okay, measure the distance between those 2 reference plates. Okay, if you are going to use a mechanical devices, you can measuring device, you can use this. Otherwise, directly you can measure the exposed length. If you are not going to measure the exposed length directly, then we can go ahead with these reference plates. Next, for testing with curved surface, that means if there is a curved structure instead of flat surface, 3 probes are driven individually using a single probe locating template. In either case, the measured average value of the exposed probe length may then be used to estimate the compressive strength of concrete by means of appropriate correlation. So you are going to measure individually instead of measuring the 3 devices or 3 probes that you are going to penetrate inside the concrete member. Is it clear? So like this, we are going to perform the penetration resistance test. I will repeat. Okay, so this particular penetration test resistance, okay, they are going to insert the probe inside the concrete member. Okay, so that particular penetration will depend upon how much the reinforced concrete member is strong enough to resist that particular probes. Okay, if that penetration is not going to penetrate more depth, that means the concrete quality is good. If that probe is going to penetrate more, means automatically the exposed length will be very less, automatically the quality will be very bad. Okay, so vice versa. So like this we are going to assess the strength and the quality of a concrete. So I am going to play a small video how they are going to perform. So please visualize this video so that you will come across, okay, what actually I am going to explain, or I have explained the procedure. Is it clear? Okay, let us see that video. So please see here. So he is performing the thing. Okay, see here. So this particular person, okay, is using a probes. You can see here. He is using, these are all called the probes. Okay, and this is called a measuring device. Okay, the measuring device, and you can see this is called a gun. Okay, which have been showcased. Okay. Now he is preparing the surface. Now he is preparing the surface. You can see he is preparing. So this is what I call template. Okay, this is what called a template. He is cleaning the surface. Okay, later on he is preparing this particular surface with a template. See here. So this, with this template, he has created a triangular pattern which have been mentioned. So he has created a 3 triangular marks. Okay, now he is going to load that probes. He is going to load that probes. See, he already loaded. So now he is going to penetrate these probes through this, so that that penetration will be uniform. Okay, so now see, once again he has loaded the probe. He has loaded the probes. It's just like a barrel. He is going to load the probes. Okay. See, he is loading the probe. He is getting ready for the next driving the penetrator. Okay. See, in the next, see, this is already driven. This is the second one. See, once again he has penetrated the probes. Okay, in the second point, second corner point. Okay, see here he is removing that nut. Why? Because please observe, this is very important. We need to measure the length. Okay, that's why he is removing that nut. Whatever have been mentioned, 12 point something mm diameter, he is removing that nut. So now it is getting ready for the third penetration at the corner. Okay, you can see here they are going to penetrate with the third. Okay, so now he is penetrating the one more probe he has penetrated. So all the 3 probes he has penetrated now. All the 3 probes he has penetrated, and now he is removing the last nut. See, now this is the exposed penetrated portion now. See, is the chipping off that particular portion so that he can measure. See, from this particular reference area I need to measure. So that's why he is chipping off that particular surface. Okay, you can see here. Okay, now see, that's what have been mentioned. So this is what called a reference plate. This is what called a reference plate. So now from this reference plate to the top, okay, from this reference plate to the top, he has measured the exposed length. He has measured the exposed length. You can see here. So that's what have been measured. Okay, told or explained. You are going to measure the 2 reference plates. So these are the 2 reference plates. So and again, once again, the second corner is going to chip off. He is going to chip off the second corner. Okay. Now he is going to insert that reference plate one more time. Okay. Now again put that top reference plate. So now we are going to measure the difference between the two. Okay, note down the reading. So what is the exposed length? Okay. So like that you will be keep on taking a readings of this exposed length of a props. So like that we are going to perform this particular test, or Windsor probe test or penetration resistance test. You can see the third one also is going to measure. Okay, so like that you will be measuring all the the corners. Okay, so he's going to measure. So like that he is going to perform the test that is called Windsor probe test. Okay, so like this we are going to perform the Windsor probe test. Next we will move on to the next test. Hope the concept has been cleared in the Windsor probe. Okay, so lesser the I can say the penetration, that means the exposed length will be more, better the quality or strength of a concrete. If penetration is more means exposed length will be less, that means the quality or strength of a concrete is bad. So like that they are going to correlate. Okay, so the length will be correlated with the compressive strength. Okay, so next is pull out and pull off test. Let us see what is that. A pull out test measures the force required to pull out from the concrete a specially shaped rod which enlarged and has been cast into the concrete. So now it is an improved version, or I can not improved, sorry, improved version. This is the one more method I can say. So there you used to insert the probes inside the concrete member. Here using a different mechanism, you are inserting the rod. Okay, you are going to insert the rod inside the casted concrete, and later on you are going to pull out that. Okay, if you are going to use a more force to pull out that particular equipment, that means the strength of a concrete is good. Okay, in the last, in the first one, that is Windsor probe test, what I have explained. Okay, more the exposed length, more will be the strength of a concrete. But in this case, whatever the penetration have been did, if I am going to use a more force to pull off or pull out that particular equipment from the casted concrete, that means I am using a more pressure. That means what I am trying to say here is the quality or strength of concrete is good. Next, that's what, the stronger the concrete, more is the force required to pull out. So like this, there I used to correlate length versus strength. That means more the exposed length, okay, of a prop, better will be the quality or strength of a concrete. Here, more the force required, okay, better will be the strength and quality of a concrete. So like that I am going to correlate. Is it okay? Next, the ideal way to use pull-out test in the field would be incorporate assemblies in the structure. The standard specimen could then be pulled out at any point of the time. So that's which I am going to showcase now. The force required denotes the strength of concrete. That's what. More the force required, better will be the compressive strength of a concrete. So these are all the three tests: internal fracture test, the capo test, the limpet test. Okay. So in this, predominantly use this internal fracture test. So let us see that how they are going to perform. It is the pull-out test which is more widely used in the field. It was first developed for testing high alumina cement concrete, the concrete which is containing high alumina cement, okay, components. But further work has been carried out to procedure correlation curve. The correlation curve will be, that is compressive strength, okay, the versus the force you are going to use to pull out. Okay. To carry out this test procedure, okay, let us go with the procedure. To carry out this test, 6 mm hole is drilled. 6 mm hole is drilled to a depth of 30 to 35 mm. 6 mm hole is drilled to depth of 30 to 35 mm, and the hole is blown out, and each hole should be at least 100 mm apart. So you are going to blow out, because whatever the dust will be there, you need to blow out that. Okay, and each hole should be at least 100 mm apart and drilled away from the reinforcement. So the reinforcement should not get disturbed. So in between that reinforcement, you are going to drill that, okay, 6 mm diameter hole with a depth of 30 to 35 mm, and each hole should be at a 100 mm distance apart. That means almost I can say 10 centimeter. Okay. Next, it is usually to carry out 6 tests on a member. That means 6 holes will be drilled. And the average of the 6 maximum reading is used to read off the mean compressive strength from the calibration curve. Okay. So you are going to perform the 6 readings. Okay. The average of the 6 readings will be your compressive strength value. That means you are going to take out that particular, what I can say, the force. Okay, based upon that calibration curve, what is the force? Based upon the force, you are going to correlate with the compressive strength. So this is what the equipment they are going to use in order to perform the pull-out and pull-off test. You can see here. So this is what the rod I have been mentioned. This is the concrete member. Okay, and this particular stand will be firmly fixed. Okay, and later on they are going to perform this particular test. That means this particular rod will penetrate inside the member, and later on this is the handle. They are going to apply the force in order to pull off this or pull out this particular rod from the casted concrete. Okay, so like that they are going to perform this particular test. So hope this concept has been clear. As you can see, they are going to perform. See, that's what, this is the rod. Okay, this is an assembly. Okay, you can see this is the handle. Okay, they are going to use in order to putting a pressure. You can see this is a pressure measuring gauge. Pressure measuring gauge, you can measure the pressure. Okay, so like this they are going to perform in order to conduct the test. So hope the concepts has been clarified. So these are all the 2 tests I am going to use in order to perform the semi-destructive method of testing. So today we have been learned the penetration resistance test or Windsor probe test, and the second one I have been explained is pull-out and pull-off test. Is it clear? Is it clear? In the penetration resistance, I used to correlate the exposed length in terms of compressive strength. Here, force in terms of compressive strength. So these are all the things are going to do in this particular testing equipments or testing techniques. So few more semi-destructive testing techniques which I am going to discuss in the next session. Thank you for this session.